Hello, audible? Am I audible?
We are able to
Yes,
hear you.
sir.
Yes, sir. Thank you. Thanks a lot. Okay. I just want to make sure that once at least before I start. Okay. I have started the recording and welcome you all to this third day of our networking concept class, Zoom class. On behalf of Eastern Academy, I welcome you all. And as we know that you can always contact me on my WhatsApp, any issues or anything on the recorded lectures if you have viewed it, if you have a doubt or anything. So with that, I'll get into the session directly. We don't have a time because yesterday itself we know that we have exceeded. Now we have discussed day one and day two. And day one we have discussed about data communication, and day two we discussed about various network types, ring, star, and everything. Those are all just ideas, how the history is knowing. But from today, what we are discussing will be slightly more valued ones. Okay, so that will be very critical one. So we are going to discuss about MAC and IP. What are these things? Okay, so and let's go to the small to 10 minutes brief of what we discussed the last two sessions. One is communication. We have a station A and we have a station B. And station A communicate B through wire. When I just mentioned wire, it could be anything. It could be as we mentioned, wired or wireless or optical. That means that A communicating to B. That's all this wire. Same way, there is a one more wire. B is communicating A. This is called full duplex. When A talk to B and simultaneously B can talk to A. That means there are two wires are there. Now, A can send 0. That means that switch is off. B can send to A 0. That's all. So it means that my switch is off means 0. That's why I told you switch. And today I'll slightly go into the detail how exactly that is implemented inside the hardware. Okay. So we also have to know that little bit. Somebody it may be confusing. Somebody please forgive me for others because somebody may be interested. So I have to go to sort of a balancing game. So those who understand it tough, please ask me in the WhatsApp. I'll try to do that. Same way, when I put the switch on, so see that I do see the whole world is now communicating only with these two, 1 or 0. That's the beauty of it. Okay, 1 or I can send 1 or 0. That's all. Now, what I send is called TX. This is a general terminology. The BTX and then RRX. So transmitter can connect to RX receiver. Transmitter can connect to receiver. That's all. Okay, this is what the connections all about in the bottom layer. Of course, there are some important informations which we will discuss today. Now, the same thing using the 0 and 1, we try to send a byte or 8-bit. Okay, that's what we did it. So we send a start bit and we send about 7 bits every 1 second, 1 bit. Then we send a stop bit and parity bit and stop bit. To include the parity, we have reduced this 8-bit to 7 bits. So what we discussed was to send the 7-bit data, that is 0, 1, 1, 0, 0, 1, 1. That 7-bit data, we used 10 bits. That's a 30% wastage. Then see here, same way, our B will start doing it. He sent a start bit. He was sending a data 1110, 110 and send the parity bit and send the stop bit. Okay, so while A is transmitting B, there are 1, 2, 3, 4 ones are there in data. So he added one extra into the parity bit because the agreement is odd parity. But while B is transmitting to A, see that there are 1, 2, 3, 4, 5 ones are there. Already odd number of ones are there. So what the B did, he added a 0 to the parity bit. That means that in the 8 bits, always the transmitter responsibility to maintain number of ones to be odd. So you can either add it, don't add it. That doesn't matter. But in this case, the B to A, you don't add. Whereas A to B, you add that thing. So that's the way it detects. So some small information we will discuss today. What are all the problem faced? Then this is called asynchronous communication, because we just have a switch. That's all. We do not depend on anybody. We just control the switch. That's all. I'm not worried. I am not depending on anybody else. I do myself independently. If you do anything independently, they call this as a asynchronous. Okay. But the other one, see here, this is called synchronous. What we discussed was the data we transmit that depend on the signal called clock. What we discussed was whenever I transmit a signal 1 and 0, I transmit one data. Then every clock I was transmitting one bit. That means that I have used 1, 2, 3, 4, 5, 6, 7, 8 clocks to send 8 bit. So the clock is nothing but on or off. Nothing. Don't take anything big. Clock means I have a switch. I put the switch on or off. Now the trick is that what is the time duration between one rising edge and the other rising edge, okay, or falling edge, whatever it is. If you see from this side, it's a falling edge. If you see from this side, it's rising edge. Okay, so it's actually coming from this side. So because he is transmitting, this is the first data. Now the T is a time. You can press it. The T could be 1 second on and off like a pendulum. In that case, we call this as a clock speed is 1 hertz. That means that you are transmitting 1 bit per second. If the duration is 1 second, then you are transmitting only 1 bit. Now you see here, if it is 1 millisecond, that is 1 by 1000 of a second, then the clock speed is 1 kilohertz. If it is 1 microsecond, then the clock speed is 1 megahertz. Now, if it's a 1 nanosecond, then the clock speed is 1 gigahertz. Then think 1 gigahertz means I am transmitting 100 crore bits per second. Think of it then, what is 10 gigabit or 100 gigabit or 400 gigabit? Think of those, how the world is going towards the speed. We are racing towards the speed. Okay, this is not exactly the trick. Actually, computers are doing nothing. All done because of the speed. You could today hear something called artificial intelligence, machine learning, everything. All of them are happening because of only one reason. That is because of the speed. Okay, so that is not the purview of this lecture. So we don't do that. I'm just giving you the very, very critical information. Clock speed matters everywhere. How fast I'm doing. Now, then what we discussed was network yesterday. We had about now 6 systems. 1, 2, 3, 4, 5, and 6. And we connected them in multiple ways. Okay, but let us not get those things. But we thought we will make this everything as a network. That means that everybody is part of this network. What it means, if all the 6 people are belong to this group, that means that this group, anybody can talk to anybody. 1 can talk to 4, 1 can talk to 2, 1 can talk to 6, 1 can talk to 3, or 6 can talk to anybody can talk to anybody. Okay, there we discussed about so many methodologies. One is called ring topology, where 1 is connected to 2, 2 to 3, 3 to 4, like that. Then next one is called star, where everybody talk to the central machine, and the central machine will find out the address and pass on the things. The third one is called bus, where all of them are connected through one wire. Okay, that's what we discussed yesterday on the bus topology. And fourth one is, which we have not discussed, that is called mesh. That means that I can simultaneously talk to many people. Think of it. I have right now, I am Balaji. I want to talk to Ganesh and Raju or James. I talk to only one of them because I have only one mouth. Think of a case, I have 10 mouths, like Ravana. I have 10 mouths. I can talk to 10 people simultaneously. And I have 20 years. I can hear from 20 people. that is called mesh. That we will discuss later, because mesh is the technology used in typically in the wireless, not on the wired. Wired, we cannot do wired. If you have so many wires, this will be so clumsy. That's why mesh was used in the wireless. Since that is not the easy to discuss now. We'll discuss later. That wireless part we will discuss later. Or I'll do one thing. I'll record the wireless thing and send it to us videos. Please remind somebody. Maybe not this week. Next week I will do the job. Okay. So now when we on the network, what we did was we have. I want to talk to 5. That is who 1. What the 1 did was he first wrote 5. I want to talk to 5. When you take a cover, you write the to address first. Then you will write the from address. Now they know that, oh, where it has to go, who is sending. Now third one is that contains how many bytes are there. Okay, now this guy is having a 4 bytes. That's why I written 4. Then I have the data 10, 15, 20, 30. These 4 are called. Actually, what happened? I want to transmit only the 4, 10, 15, 20, and 30. To send this, I have to add these 3 prefix. Okay, or generally we call here as a header. Then we have a 85. Am I right? What is 85? It's a sum. You total everything. 30 plus 20 is 50. 50 plus 15 is 65, 75, 80, and 85. The sum. By chance, while I am transmitting the data, when it goes from 1 to network, if 10 get changed to 9 or 15 get changed to 14, that's all. That guy will, network will total everything. Oh, I've got 84, man, but checksum should be 85. Then gone. But by chance, there's a possibility. 15 get changed to 14. 85 get changed to 84. What will happen? There are possibilities. Am I right? In that possibilities, we don't have the option. So that how we will do it. Those points we will discuss today. Sometime I do mistake, and even since I'm new to this Zoom, I'm not able to sometimes allocate the time. These are all first classes. So I thought I will complete in 5 days, or it's happened for the very first modern electronics to C programming and embedded. At least I should have been slightly careful on this also. But there is always going on 2 people are fighting with me. One is a fact and feeling. Fact says, Balaji, you agree some date and finish it off. But the feeling says, no. It is your responsibility to make the people to understand. If I have to make to understand, then I should not worry about the time. So I do not normally worry about the time. If the last class, if I could not complete it, I will extend 1 more day, or I will send the recorded one. Whichever you want, we will do the thing. That we will discuss tomorrow, day after, how we are going about it. But I do not want to go rush up. I wanted to make sure that you understand. Okay. Beauty is this data, the first A01 prepares. He does not start sending. He prepares how many bytes are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 8. There are 64 bits are there. What this 01 does, he sends the 64 bits to the network. Then the network gets the data. He sees. Then he will send it to, it goes to 5. How it is going? Yesterday we discussed. You go and repeatedly see the video of second day. You will fairly understand how we are doing it. Now, done. Now it takes 64 bits. Okay. If your clock is 1 megahertz, it will take 64 microseconds. If your clock is 1 gigahertz, it will take 64 nanoseconds. If your clock is 1 gigahertz, it will take 64 milliseconds. So the data from my computer to go to other computer, the time depends on the speed at which you are transmitting. That's why people are saying that, hey, now I'm giving you 100 Mbps. I'm giving you 10 Mbps. Okay, that is what all about your 2G, 3G, 4G, 5G, 6G, all these things are all. How speed I am transmitting and how far I am transmitting. Those are the 2 things. Because if I reduce the speed, I can go for longer distance and it will be cheaper. If you increase the speed, I cannot go for long. I have to go for shorter distance. And how do I do that? That's a trick. Okay, because of the technology called DSP, digital signal processing, things are changed. Even though I could do nowadays higher speed for higher distance. That's why the thing. So now we with this we will get into the board. I will explain to you some important fundamentals. Before that, let me just discuss about this packets. Okay, now in this packet, this one we call packet. In this packet, the 05, we call it as a to address or destination address or DST. Anything is fine. If you hear anything, it is called first address. The first byte is that. The second byte is called from address or source address, or we call it as a SRC. So industry use these terminologies. The first byte is DSC. The second byte is SRC. The third byte is length. Okay. Then this is called data, or industry sometimes call this as a payload. Okay. This is called data. And the fourth one is called, that is fifth one, that is to, from, length, data, and then last one is called checksum, but industry also call this as a CRC. No. Packet sizes, you put length as instead of 10, you can add 10 bytes. If you add length as 100, you can add 100 bytes. So it's based on the packet size is not flexible. That's what I'm going to discuss here. Today, I'm going to discuss about the packet size, how exactly it happened. Okay, 2-3 informations, very critical, that I'm going to discuss today. Okay, the packet size is flexible, where you can always send the data as what, 0, 4. Instead of that, if you want to add another few bytes, I can add it and increase the length. That's the only thing. So it is possible. Not only 8 bytes. This is not like a frame relay. There is something called frame relay. Okay, that's the communication. That's the fixed data bytes. Okay, but here it is. Ethernet is having a flexible one. You can do any amount of data. Now, let's get into the board. Okay, so let me stop this share. If anybody is having any doubts now, you can ask me now. Whatever, this is what we discussed yesterday. Only we spent about 15 minutes for refreshing yesterday's thing. That's why I told you that if I don't refresh this, discussing today's topic will not be very interesting. There are some small information which I told you. The trick is that in asynchronous, I use only one wire. In asynchronous, I use only one wire. That is fine. But okay, so but in synchronous, we use 2 wires. So synchronous having 2 wires, asynchronous having only 1 wire. But industry don't want to use asynchronous because 2 problems. One is speed, because both the sites will be running a different clock. Then the second problem is I'll tell later. That's what I'm coming today. Today I'm going to discuss about all these things. Okay. The second one is, the first one is speed. Am I right? The second one is 70% only, 30% loss, because you send one start bit, one stop bit, and one parity bit. To send 7 bits, you are transmitting 10 bits. So because of that, there is a loss. So we have two issues. The problem what we are facing is, one is due to the, one is no, they are different. I'll discuss about that. I'll discuss about throughputs and dot later. Okay. Now the trick is that I have a station A and I have B. I use a wire for asynchronous, but I have a problem. So I use synchronous. It's very good. I can change the clock one side. So there's no problem with a clock. I can transmit any speed because I change the clock. B does not have to be having the clock. Since A sent the clock, no issue with the clock. But the problem is, I'm connecting about so many systems. I have to start keeping 2 wires. So industry thought they want to be synchronous. They want to be. This is a topic which some of you may not like it. Please listen to it. It will be useful to you tomorrow, but not today. And because I have to discuss this. The trick is that I want to be a synchronous. That's exactly like this. I do not want to study during the college days. I also have to get a good mark. What you will do? That's a technique. I wanted to spend the time on watching movies and everything, and during the semester, but on the semester and the exam, I want to get 9 CGPA. Am I right? That's what every student wish. Unfortunately, that's not happening. But here in the technology, people wanted to use synchronous, but they don't want to transmit a clock without clock. But then you say that, how could it possible without a clock I can able to make it as a synchronous? Because the moment I set the clock, if I don't send the clock, it becomes asynchronous. No. Clock is that. Like a asynchronous, they have a clock here, they have a clock here. So they have a clock. Now I'm transmitting 1 megahertz. I'm also having 1 megahertz. There's a clock. But unfortunately, see here, these clocks are all, I told you, used from the quartz crystal. They are used with the quartz crystal. So this clock is also quartz crystal. This is a very natural way. This clock is generated using a very natural way. You don't have a control when to start, when to stop. The clock will be oscillating itself. So if you take 2 clock oscillators, think of it. This is a very, very important information. Okay, there were 2 clocks, clock 1, clock 2. Okay, now clock 1 is going to oscillate on and off the output. And let's say this time is 1 megahertz. That means the duration is 1 microsecond. The duration is 1 microsecond. Now the same way here, the clock 2 will be oscillating. This also will do exactly. This second clock also will do exactly 1 microsecond. But unfortunately, you want this here. This one is on it different. So the timing of on and off is totally different. They will be totally independent. You do not have a control. But we discussed Yesterday we discussed. Understand, this is very clear. When I have a two people, two clocks, I have a A and B. A is having a clock 1, B is having a clock 2. Both are not same. The timing could be same, 1 microsecond, but they will not be at the same time on and off. For you, when it is on, for him, it could be off also. But we discussed yesterday, we send the data, the transmitter send the data on the rising edge of the clock. I send 1. Every time, whenever there's a clock rises, I send data. So for me, while sending, I reference my clock. But understand one thing, when I send my clock from A station, send the clock to B. No issues. When A send to B, no issues. But unfortunately, when you don't send the clock, if you ask, the clock is generated at the own place, they are not synchronized. Okay, they are not, the timings differ from A to B. To avoid the problem, what people did was, they did a very small, nice thing. That has to be understood. That everybody could have studied, but may not really know that what it is. Here also, see, I'm not discussing with the networking with only, except only a few of you may not be knowing about networking. A lot of people heard about networking very well. I know that. But what they do here is, I have a 1 megahertz clock, which is oscillating every 1. This guy, B, also having a clock. B is also having a clock, which is how many seconds? 1 megahertz. But what is happening is, this guy and this guy timings are not correct. Now what is happening? Somebody here who gets the clock first, not your B. Before it go to the receiver, in between somebody will get the clock. And this clock goes here also. Okay, both the clocks are going. Now A clock is going to this guy and B clock is going to this guy. And that guy will send the clock here, which will be same as a clock. Think. Now I draw the block alone separately. Now what happened? There is a block who receives a clock from A, who receives a clock from B. The problem is the clock of B, who receives the clock from B. The problem is this guy clock is like this. The B clock is like this. So see that there is a gap. That means that you on the light now. Other guy will on the light after so much of delay. Okay. The delay could be some whatever. You cannot predict because nobody knows the delay. But this guy will check the delay. Who? This box. After checking the delay, what he will do, there is a 2 clocks. Let me draw only 1 clock. Then you will understand. This is A clock. This is a A clock. And this is the B clock. Now you see that there is a difference here. There's a difference here. Okay. That difference is the one which we do not know. We don't have a control. That's why this guy will detect. This guy will detect the delay from both the people. From both the people, he will detect the delay. Once he detected the delay between these two people, then what he will do, he will give to the other unit the delay. How much is the delay? Okay. based on the delay, this guy will delay the B signal. Now you know that here there's a delay now. This delay, this guy who that shift, what that guy will do, this guy will delay the B clock, will send it out. So when you delay it, then what happen? This clock will get delayed and it goes here. This guy, since it's a delay this much, this guy will start here. So I delay this much, not this much. This positive edge to this positive edge. The delay is this much. So he will delay that much. So this guy, instead of doing here, this guy will start from here. Now both the guys will become. So this clock, the clock coming from A is getting this one checked here, and the B clock is delayed and given to him. Okay, we use the A clock to check. But where's the clock? We are not sending the clock in A because we remove the line. We remove the line. For that reason, we do some important thing. This, you know, what is this called? This I'll tell you somebody where it's not, I don't want to confuse you, but at the same time, if you know a circle is having 360 degrees. This start from 0, 90, and then 180, 270 degrees. We know that. This, yeah, exactly. This is called PLL. Perfect. Okay, that is what I'm coming. In thing, this degree, 30, 60, these are all called phase. So what happened in a thing, we normally write a sine wave. Am I right? It's easy to understand. The sine wave, this is 0 degree, this is 90 degrees, this is 180 degrees, and this is 270, this is 360. The same thing here, and this difference is called phase. This is 90 degrees, this is 180 degree. So if you take a square wave, also a clock which is square wave, this is 180 to 360 degrees. This is 180 degrees. This is 90 degree. So what happened? What normally people say is, if there are two clocks, this is a clock 1, this is a clock 2. The difference is phase shift. Because of this phase shift, the synchronization is lost. What we do here is, this guy is detecting, there is one guy detecting the delay, how much is a phase shift, other guy is offsetting the delay such a way that what is going out is synchronized with the A clock. But we know that it's fine. So when the A clock is coming, I could use directly A clock itself. Why I have to do these things? The problem is, in the communication, I wanted to use only one wire. But I want to use this wire as a clock as well as data. So what industry thought, first some time till the B guy detects a delay. This clock and this clock is coming, this guy coming. So this guy is detecting. That's called PLL, phase lock loop. That means that he is locking the phase with this guy. And they call this is digital. They call digital phase lock loop. Now forget about it. I'm not trying to confuse you, but this 15 minutes, those who don't understand, please leave it. It's not very essence. But what is happening inside the system, you should know that what is happening is, clock is the most important. And even though you don't send the clock, what everybody is saying that, first what I do here is, before I start sending my data or packet, I don't send the data or packet. I put the switch on and off. So I indirectly send the clock to him. Am I right? Whenever my clock is pulsing, on and off. I transmit 1010 like that. Data is going there. So this guy take this as a clock and he finds a delay. So initially they said people found out, okay, initially they sent 7 byte or 7 into 8, 56 bits. They use the data itself. They have only one wire. On the data wire itself, they transmit a clock. That is, if your clock is 1 megahertz, I send 56 microseconds or 56 clocks. This guy, the B guy, supposed to find the delay between the A clock and B clock within the 56 microseconds. If you don't find out the delay, then gone. I cannot do anything. It is the responsibility of the hardware to find the delay within this 56 microseconds. You know what this called? Since I sent before the data, I call this as a preamble. It's called preamble. That is, I transmit 7 byte. I transmit 7 byte. So initial 7 byte is waste. I transmit 7 byte, that is 56 bits. So what I do here is I use the same wire, one wire, as a clock. That clock name is called preamble. I send the clock from place A to B for B to detect the delay. And so what, by using this 7 byte, I am making advantage. I don't have to use the one more wire. To remove a wire, I do that. That is one. Second problem is, how will I know that after 7 bytes, this guy clock and this guy clock are same? So clock means 0, 1, 0, 1, 0, 1, 0, 1. But what our man did, in the 8th byte, after 7 bytes, I'll not send 0, 1, 0, 1, 0, 1, 0, 1. I will send 0, 1, 0, 1, 0, 1, 1, 1. I change the 1 byte, 1 bit. If this guy received this successfully, then that guy will know that, oh God, good man, I'm synchronized. Both the clock are same. If this guy is not receiving a data, then what will happen? That data is lost. That means that they have not synchronized the clock. The whole communication become waste. But nowadays, because of technology, this is not happening. We are able to synchronize the data perfectly. This is called 7 bytes, and this data is called SFD, start of frame delimiter, SFD. Yeah, preamble is nothing but a clock. We call it as a preamble, but I have only one wire. What the B is telling to A, Baba, do one thing. You do not send me the full clock always. Don't require to give. You give me only few clocks. You give me few clocks. Within the few clocks, I will synchronize myself. I also having a clock. But unfortunately, my clock and your clock are not going with the same phase. They are different timing. I wanted to detect what B is telling. I want to detect the time. To detect the time, don't send me only one clock. I may not be able to detect. You give me some clocks, then I will perfectly do that. I may do it with 20, 25 clocks. But industry said that to have the reliability, in the industry, transmit 56 clocks. But I am actually sending clock. What happened? Before I transmit the data, I send the clock 1 and 0. 1, 0, 1, 0. 1, 0, 1, 0. Okay, but they call, the standard, they call this as a preamble. Okay, I don't know. 1 minute, me. Sometimes my English is a big problem. I lose the spelling mistakes. Yeah, it's correct. I'm right. It's BLE, preamble. Okay, it's a cap B, not P. Okay, preamble. So this preamble is actually a clock. That clock is exactly 7 byte. That is 56 bits. That means that I'm transmitting 56 clocks to A to B. If B is not receiving the 56 bits, then they will lose the data. Okay, that's correct. Now, please, today's lecture alone, you watch it 1 or 2 times, then you will understand. It's very important. If you listen to me a few times, you will try to understand. After 7 bytes, A is transmitting one we call SFT. SFT is nothing but what? 0, 1, 0, 1, 0, 1, but 1, 1. If it's 0, it becomes a clock. I transmit. Yeah, exactly. They are sending only 56 clocks. Within the 56 clocks, if I don't detect the clock, then I don't do that. Okay. Correct. After 56 clocks, no. After 56, I don't send data. Please understand. How do the guy make sure that he's synchronized the clock? So I send it once again one data, 1 byte called SFD. That data is 01, 01, 01, 11, not 01. If it becomes 01, it becomes clock 11. Now, actually 8 byte. So 8 into 8. We spend 64 bits initially to make sure that I am synchronized. Then only what we discuss, all the things are happening. So what I do here is I transmit something called preamble. Then I transmit SFD. Then I transmit to address, from address, data, and a checksum or CRC. Okay, that's a trick. I'll give you the difference between the checksum and CRC now. Afterwards, I'll complete everything. Even I explained up to the level of what is preamble, what is SFD. Okay, then is a problem. Okay, what happened was this is a network. Am I right? This is a network. How I do was I have a memory. I have a memory in the system. You know memory. Memory is a data like your SD card or RAM, ROM, everything. So I prepare a packet 05 from 205 from 01 and data is 10, 20, 25, 30. Then checksum is I add all of them. Then let's say we put 15, 20, 30, 50, therefore 85. I prepare everything. What I do here is I write the data here sequentially 05, 01, 10, 15, 20, 30, and then 85. For you notebook, in computer or a board, in computer the same thing is memory. Who is writing into the memory this data? That guy is microprocessor. Okay, and who tell the microprocessor to write? That is your software. Microprocessor cannot do anything. So Balaji is writing on the whiteboard. Okay, Shyam is writing on the notebook. Am I right? Like that, microprocessor is writing into the RAM. It's called RAM, read write memory or RAM. Now Balaji has written this data and given to Raj. Raj is the one who is going to operate the switch. Okay, now what Balaji did was, I wrote this data in a paper 05, 01, what Balaji did was, and on a piece of paper, Balaji has written 05, 01, 10, 20, sorry, 10, 15, 20, 30, 85, checksum. Now 7 bytes are there, as we discussed. Oh, I forgot to put the length here. Sorry, add a length. Forget about it. Otherwise, why do you do it? 05, 01, 04. That's a length. Here also. Let us not leave any mistake. 05, 01, 04 is a length, 8 byte. Now, this is RAM. But Balaji is written on notebook. Balaji has written on notebook. And Balaji gave it to somebody. Who? Ganesh. What Ganesh did, he read the 05. Then he operated the switch based on the clock. He operated the switch. Oh, 05, 0000, 0101. 1 means 1 on, 000. Then he was on. Then, after sending the 8 datas, then Ganesh read next one. Then he will send. So, Ganesh used 64 clock to transmit this byte. Okay. Now the same thing happened here. The microprocessor is written into the memory. There is somebody here. There is somebody here who read from the RAM and send it out bit by bit. Am I right? Who sent it out to the bit by bit. This is clear. So like how come Balaji, notebook, and Ganesh and the switch? Okay. The same thing here. Okay. The same thing here happening, but this guy is different. That guy is a box. You know who is he? Normally we call them in the boards as a controller. Like we have a cook at home. You tell the cook the item. You have a driver, cook, all of them are human beings. Like that. Here also in a computer, there is somebody called controller. That controller is called network controller. The network controller, the name is network controller, forget it, because I have a USB controller or hard disk controller, I have a display controller, so many controllers. Whatever operation I'm doing, if I'm driving, I'm called driver. If I'm typing, I'm called typist. Am I right? I'm whatever name you call, okay, carpenter. If I'm doing carpenter, I'm called carpenter, like that, okay? Like that here, there is a hardware. There is a hardware is there. Forget about this, electronics. There's a small piece of electronics. Okay. That small piece of electronics read from your notebook. For you, notebook. For them, it's a memory. For you, it's a microprocessor. Here, Bala is writing. But microprocessor, you know that it's a slave. He is controlled by the software. The software is written by the human being, a programmer. Ultimately, a programmer write the software and give it to the microprocessor, write it to memory. This programmer writing software is called network programming. Okay, now let us do this. Let's not delay that more, because already we have Ghostman. It's already, but no problem. I told you, I'll somehow manage it. But I don't want to leave this topic, because the network controller you hear everywhere. Okay, and the network controller, give it to somebody, the switch controller. Okay, what the network controller thing is that he will do the whether I'm getting a data, I'm getting a checksum correct or not. The to address, from address, all of them are added by the network controller. Whereas this guy, he is the one network controller. does not add your preamble or SFT and synchronize the clock. All those things are not done by the network controller. That is done by another guy. That guy is called PHY or physical controller, you can call. Okay, that guy is the one. Whenever, let us say, what is happening is the network controller gets the data from the memory, from the microprocessor, then he adds from to address, then checksum, CRC. This all done by the network controller. And then he is the one who will send this one to the PHY device. That's called physical device. This guy will send it outside. But so see the difference here. Understand one thing. Understand things very clear. This microprocessor is giving data. I want to transmit data 10, 15, 20, 30. When it goes to network controller adds to address and then from address and the 4 bytes, then data, but the checksum. These are all calculated by the network controller job. That is not microprocessor job. You give only a data. But the same way, when it gives to the, see, when here it goes, please understand the difference here. From this guy to this guy, let's say we call 3 people, A, B, C. When A give 10, 15, 20, 30. This is what giving. He is giving data. A giving data to network controller. What the network controller does is, he is adding, he does not know what it is, but he is adding to address, that is 05, from address 01, length is 4 bytes. Then he add the sum. The sum is calculated by the network controller. He does. Then he give it to the PHY. What the PHY does is, he gets this full information. He gets the full information. Then he add SFT, the preamble. Okay, he does not add anything on the back. Now, the problem is like this. Let us take a case. There is a guy, okay, who is responsible of the company. Let's say you call it the manager or director. A manager writes a letter. Okay, that's all. He writes a letter only. Then he will type the letter and sign it. Then he give it to the receptionist. That is, a manager is giving it to receptionist. Receptionist only is not where it has to go. Receptionist write the to address and the from address on the letter. Then give it to the other person who is going to do the postal service. He will post it. He will paste it. He will stick the cover with the glue, or he staple it, whatever it is. He makes sure that is safe. If it is not there, if it is not safe, then he will put it to another cover, whatever it is. His responsibility to send his responsibility is to make sure that the packet is, he does not worry about what is inside the cover. He does not worry about what is the to address. He does not worry about what is the from address. What is the guy's address, the employee's responsibility? You may call dispatcher. his responsibility is to cover have to go safely. Then this cover go to the other person. Then the other person makes sure that he receives the cover. That is what the other 5. This could be at Chennai, this could be some other place. Then that guy give it to the network controller, the data. What data? 05, 01, 04 and data 10, whatever it is. Then he gives the sum. Sum is 85. Then the network controller receives the data, okay, and checks the sum, find everything. See, this guy does not check it. The checking authority is this guy. And adding the from address, to address, from address, and the thing. This has to be understood very clearly now. I will explain it once again tomorrow. Okay, whose responsibility is what? That has to be thoroughly understood. Watch this video once again today. I will once again briefly said what is this? Who is doing what? Okay, how exactly the whole world network is working. How come you press a button? Okay, here the Google Pay detects money from your account. How come these are all happening? That is, everybody know the top level ODU is happening. You press a button you go to the browser and say www.google.com. How exactly you get the Google display on your computer display? Then you have to know all these things. It goes via all these things. But you can understand and forget. But you think that the black box is something magic. No, I want to see, you may be working something else fully. But what I am trying to say is that concept of network, you may not be working on this area. But understand one thing. When you go to the real world, you use calculator. Am I right? Everybody start using calculator. Everybody has to use computer. Then why they are teaching in the school days addition, subtraction? Today calculator come, man. Why they have to teach Balaji addition, subtraction? Let us not teach addition and subtraction. Am I right? That's the easy way, na? Okay, like that. Here, we discuss every day a complex topic. This is a quite complex topic. It's not a very simple topic. I'm trying to make it as simple as possible. This is typically a one summer, but of course we know that every college we are studying so much and coming back still. Most people don't understand this or these terminologies. But I will make sure that at the end of the session, okay, you will have a thorough understanding. Okay, sometimes it may look like confusion, but it is not actually a confusion. There you have to understand how the whole industry, the engineers, did the whole process as what British did to India. How British is a small country could conquer the India because divide and conquer. Okay, they do divide and conquer. Like the same thing here, we have to make sure that we understand all these things, simple blocks. And then what happened? This guy give it to the memory. 10, 15, 20, 30. Give it to the microprocessor. That is, the computer 1 sends the data, computer 2 receives the data. What are all things had happened? When I'm sending it wire, because of the preamble, the clocks are not synchronized. This guy will not receive the data. If he is not receiving, he will not give it to this guy, network controller. So your data is lost. So what you send has not gone. Suppose this guy sends the data correctly, but the 5 does not detect due to noise sometime. The one data 20 has changed to 21. So what this guy could have received 05, 05, 01, that is to address, from address, and 04 is your length. Then 10, 15, 21. You transmitted 20. This guy received 20. This guy got 20. This guy sent 20, but unfortunately, due to the noise wire, you have a long cable. Somewhere at the cable portion, something is wrong. He could have got as 21, but 5 does not bother. 5, whatever, so, oh, I get 21, I'll give it to network controller. The 5 is not intelligent device, but the network controller, he checks, he got 85. Then the network controller will add all of them. 5 plus 0, 1, everything. He got 86. How much he got? 85. Both are not same. So what that guy will do, he will not write into memory. He will not give it to the other microprocessor. So this guy will not know that. Unless otherwise everything is perfect, the microprocessor will not get the data. That means that it is equivalent to packet is lost in the ocean. The ocean could be somebody. This guy could be faulty, 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 anybody could be faulty. But data is lost. The last data is lost. Okay. Now, the trick here is if everything is perfect, this guy checks, this guy get 10, 15, 20, 30. This is the actual sequence happening in a network. And everything is called different name. In the industry, this is called physical layer. That means that whatever you do, the data have to go there physically. Even I told you, even wireless, the electrons are moving. There's something physically going. It could be optical, light ray is moving, photons are moving. So something has to be physically go from one place to other place. If it's not physically going, you will not get the information. So now in industry, they call this as a physical layer. I will write it down. They call physical layer. We call this as a phi industry. The second one, we call it a data link layer. You know what we call? We call this as a MAC. What is MAC, man? How come suddenly it should be called DLC? Am I right? Why they call MAC? It's because they call it as a industry thought. I'm used. This guy could be anything. I don't see. The data ends here. It can go here in a. What happened? It can go in a wire or wireless or optical. So this network controller is talking to the other guy. Okay, who is controlling the media. They call this as a media access control. That's called, they call MAC, MAC. That is actually, we call this a network controller. That is not network. We have something in that, some other network. They call network controller, but the job. But these two together, they put on a single cards. These two, they put on a single card. They used to call this as a NIC. That is called network interface card. That is called NIC, N-I-C. Okay, NIC is a hardware. Actually, the hardware ends here. All remaining things are software that we'll discuss tomorrow. That is actually, I have to something called, there is a, I've not, I've explained to you that this is the preamble, SFD, data link layer, whatever is MAC. This is called physical. This is called physical. Now you take the MAC one that contains two address 05, 01 from address, then length 04, then data 10, 15, 20, 30. Then I have a sum. So now in the actual standard, this is not 1 byte. This is actually 6 bytes. This is actually 6 bytes. This is actually 2 bytes. This is also 2 bytes. And the length cannot exceed 1500 bytes. Or to be exact, 1504. You know why? It's because they have detected. I told you that the clock, both the sides, A to B. This guy is sending initially a clock of how much? About 56 bits. that is 7 bytes. Within the clock, they synchronize. But unfortunately, during the transmission for a long time, that the clock, both the places could drift. So what happened? It is not admissible to send beyond the thing. Of course, later they found a method called jumbo frame. They are transferring nowadays 9,000 bytes. So 1500 bytes, they send 9,000 bytes. These things, this is exactly why they had made as a 6 byte instead of 1 byte. Why they made a length as 2 bytes. And what is this checksum? It's called CRC. Okay, I'll do one thing. I'll try to record if I time permits tomorrow, because I have so many other work. 1 hour I'll record it and send it to you before the class. If you could watch it and let me try this. I don't know how time permits for me, because I've not yet recorded this one. Okay, otherwise we'll have a class tomorrow and we will have it because today we have to discuss about Mac and Phi. I have to explain what is Mac. I have to explain this many things. Otherwise, I can say, oh, Mac is layer 2. It is called data link layer. This is called also called media access control. This sits above physical layer. Finish. I can finish in 5 minutes. That is called R&D talk. Normally, the companies will be asked to give an R&D talk. I'll talk 1 hour, and you will be thinking that, oh, Balaji has given superb information, man. I've learned everything. But when I get out of class, you go out of the class, you will not know anything. I will not know anything. That's called R&D talk. I'm trying to avoid that. That's why it takes time. I'm trying as much as possible to make you to understand. Okay, I'm trying to do real life comparisons. Okay, and in spite of that, sometimes it may not be possible for everything to understand, because it's all quite new to you, because I lived in this field. But I'm trying. Okay, but after this information, if you go and read a book, or if you read any YouTube videos, or if you go on the terminology of Mac and 5-frame, Ethernet, everything, you will start understanding what is happening. But don't forget to this. This is a very critical. What I told, out of what I told, this is a very, very critical. Microprocessor puts the data in the memory, and then this guy, network controller, takes the data from the memory and he make it as a packet and give it to the Phi sending it to the physical device. That is cable, wire, or wireless, or optical. That is what the responsibility of Phi. Now these two together, network controller and the Phi, the network controller is called MAC. Together is called NIC. Previously in till about 2000, 2010 and on, it will be a separate card, NIC card. Today, this is coming as a built into your motherboard. Your motherboard is having a microprocessor, PC motherboard. There's a separate, the NIC card is having a separate, then it goes out. Okay, this is a part of the motherboard nowadays. And this microprocessor is controlled by a software. This software is written by a programmer. So now you know that the importance of software and the importance of programmer, because all these things are available. They are controlled by this guy. Now, tomorrow, we will discuss about how whatever we left out here, we will discuss, and then yeah, exactly. Yeah. I will come to the thing. See, there are 3 things. One is called, we have discussed only about NIC. That is a hardware. Then we have something called stack. That is part of the OS. That is part of the operating system. Above which application. Application. This application is the one which is email, your browser. All these things are applications. Okay, but bottom line is this one. Now we have discussed only this. Here is only IP and TCP are there. That's what we are going to discuss tomorrow and after. If it not possible, we will slip over to another day. So now how the application, you as a browser, how do you give it to TCP? How the TCP give it to IP? IP give it to MAC. MAC give it to PHY. Okay, these are the generally call it as a, this is called, the PHY is called physical layer. MAC is called data link. IP is called network. TCP is called transport. I will discuss all this meaning tomorrow. Okay, tomorrow and after, next 3 days. I'm not trying to say exactly what it is, because today I thought I'll finish it off everything, MAC and IP. But when I'm taking the class, I thought, oh, some points are missing. I need to better explain this because I could jump it easily, which I don't like. I do not want to jump. Okay, I may even extend 1 or 2 days extra also, but I don't want to jump the sessions. I may give few extra recorded videos to you to understand, but I do not want to jump on the sessions. Okay, thank you. So with that, I think it's become time has become 10 minutes extra today. It's fine. We'll formally close it. If any other discussion, because the most important thing is discussions, not what I'm discussing. That is